Today lectures we will discuss how to find the integral for tan when we have odd power or even power. The integration of tan to the power m, regardless of the power, was even or odd. The integration is usually solved by using the substitution method. Before we go to see some practical example, let's see this important note. The most important simplification relation used, sec square, it will be equal tan square plus 1, and cosec square, it will be equal cotan square plus 1. This important note, you need to memorize it because we need it when we solve the integral for tan. We have here another important note. You should know the value of this integral in case you need it. This integral you should know, you should memorize this type of integral because it will help you to solve some integral. Integral for tan x, it will be minus ln cosine x. The integral for cotan x, it will be equal ln sin x. Integral for sec dx, it will be equal ln sec plus tan x. Integral for cosec x dx, it will be ln cosec x minus cotan x plus the constant number. Also, this type of integral, you should know it and you should be aware of it. Let's go to see some practical example. Find the integral of the following function. Integral tan to the power 4x dx. As we notice here, we have even power. How we will solve it? Notice that for the even power, we withdraw 2 from the even power to get the quadratic exponent, and then we can use the simplification relations. We have 4, with the root 2 it will be 2. The integral will become integral tan square multiply tan square dx. And from the relationship sec square equal tan square plus 1, we will get this equation because here we have tan, then we will get tan. Tan square it will be equal sec square minus 1. And we will substitute this value in this part. So the integral it will become integral tan square, it will be sec square minus 1 or multiply tan square dx. And after open the bracket for this one, we will get this result. And from the integral property, we will distribute the integral to the function. So in this case, for the integral, it will become integral for this function minus integral for this function. And we will call this equation number 1. The integral for sec, we will try to solve this part first. The integral for sec square multiply tan square x dx. How we will solve it? We will use the substitution method. We will take u for our assumption. U it will be equal tan x, and u we will take the derivation for this assumption. It will be sec square dx. The integral will become tan square x multiply sec square x dx. This part, notice it will be du. After we putting the integral in terms of u, the integral will be equal tan square, it will be u square, and sec square dx, it will be du. The integral become easy to find the solution for it. So after finding the integral in terms of u, we will substitute the value of u. What is u? U equal tan x. For this part, the integral for tan square multiply sec square x dx, it will be equal 1 divided 3 tan to the power 3x. And we will call this equation number 2. We already find the solution for the first function. Let's try to find the solution for the second integral. Integral tan square x dx. So we will solve it by substitution method. We will use the equation to simplify the function. We will put this value in the integral. After we put it in the integral, we get this result. The integral will become integral sec square minus 1 dx. And after distributing the integral to the function, that means we need to find the integral for sec square dx minus integral dx. The integral for sec square, it will be tan, and the integral for this function, it will be x. And this equation, we will call it number 3. we will put the result for the equation number 2 and the equation number 3, we will put it in the equation number 1. After the simplification, we will get this final result. Let's see another example. Find the integral of the following function. We have the integral tan to the power 5x dx. How we will solve it? Notice that for the odd power, we withdraw 1 from the odd power, and then we can use the simplification relationship. Here we have odd power, then we will withdraw 1. We have 5, withdraw 1, it will be 4. So the integral will become equal integral tan to the power 4x multiply tan x dx. This part, we need to put it to the power 2, so it will become tan square all to the power 2 multiply tan x dx. Now we have already quadratic exponent, and then we can use the simplification formula. We have tan, then it will become tan square equals sec square minus 1, and we will put this value in this part, and the result it will become integral sec square minus 1 all to the power 2 multiply tan x dx. And after open the square expand, after the simplification, we will get this value. So this is the equation number 1. We need to find the integral for all these functions. So we will solve each integral alone, and we will substitute the value for all these integral in the equation number 1. First, let's find the integral for this function. The integral for tan x multiply sec to the power 4x dx. How we will solve it? We withdraw 2 from the sec. It will become integral tan multiply sec to the power 2 multiply sec to the power 2 dx. Then sec square, it will be 1 plus tan square. In this case, we can use the substitution method. We will take tan for our assumption, then u it will be equal tan, and du it will be sec square dx. Notice we have the sec square dx. Second step, we need to put the integral in terms of u. After putting the integral of u, we get this result, and after open the bracket, we have this value. Now the integral become easy to solve it. We just increase 1 the exponent, and we divide it to the new exponent, and we will get this is the result of the integral in terms of u. The last step, we will put the result in terms of x. The integral for tan x multiply sec to the power 4x dx, it will be this value, and we will call it equation number 2. So we already find the result for this function, and we need to find the integral for this function. The integral tan x multiply sec square x dx. How we will solve it? It is simple. We will solve it by substitution method. We will take u for our assumption, u it will be equal tan, and u derivation it will be sec square dx. We get this part. So the solution will become easy. After putting the integral in terms of u, it will become an integral u du, and it will be equal half u to the power 2. The last step, we will put the integral in terms of x. It will be half tan square x. So the result for this integral, it will be this value, and we will call it equation number 3. The last integral, we have this one, the integral for tan x dx. The integral for tan x dx, it will be equal minus ln cosine x, and we will call it equation number 4. The last step, we will substitute the value from equation number 2 and 3 and 4. We will put the result of this integral in equation number 1, and after the simplification, we will get the final result of this integral. This is for today's lectures, and I hope it is clear, and see you next time.